And now it's time for the Single Store session at the AI Deployment Summit, where we'll learn and see how to easily design, build, and deploy private or local LLM apps that take advantage of your enterprise's private data. And our guide this morning is Akmal Chandri, Senior Technical Evangelist at SingleStore. Akmal, welcome.
Thank you very much, Vance. Great to be here.
You know, we're glad to have Akmal with us. He is a first-class educator for AI, LLMs, and related AI technologies, which you'll find out soon. 25 years experience in IT with a focus these days on AI optimized database and even cloud technologies. His session today is entitled How to Build Local LLM Apps with Ollama and Langchain. You know, in an era of heightened data privacy concerns, the development of local LLM applications is an attractive alternative to cloud-based solutions for many companies. Today, Akmal shares with us how SingleStore lets you easily create AI LLM projects with the best technologies and rigorous data security. In specific, we'll learn about AI-optimized features of SingleStore, including vector database and RAG support, as well as a native compute service, and we'll also get a great demo. So today we have a great look at a secured AI ecosystem based on SingleStore's adaptive database technology. Quick note before I hand it to Akmal, you can download today's slides. Just click the big red button under the view area. We've also got some other valuable downloads, even access to a free trial for you just one click away. And we love your questions. So to ask Akmal a question, just type in the submit a question box under the view screen. So Akmal, with that, let me turn to you and tell us how to build local LLM apps with Ollama and Langchain.
Great. Thank you very much again, Vance, and great to be back. And let's get started. Okay, so in terms of agenda, quite simple and straightforward. So a little bit of an introduction, and then I'll talk a bit about some of the possibilities and ways that we can integrate AI and ML with SingleStore. And then we'll really deep dive straight away into RAG for maximum security, looking at some of the different ways that we could utilize it, okay, whether we run it locally or in the cloud, some of the considerations that we have to think about. And then we've got a couple of quick demos. And then just to wrap it up, a summary in terms of the key sort of things that we can see in terms of the benefits of Ollama and Langchain. Okay, so let's just do a quick introduction about the company. And this is a nice kind of slide because it shows you that actually SingleStore has been around for quite a long time, since 2011. And here we are all the way at 2024 now. And some key milestones along the way, as you can see. And one of the important ones is this one here, around about 2017. So vector support, obviously a popular topic today, has actually been in the product since that time. And I think it was a financial customer that actually requested that way back in 2017. So we've had this in the product for a while, but it's got better. Earlier this year, we announced some enhancements and improvements around that. As far as the company is concerned, well, over time, we have grown in terms of revenue. So today now we are a US $100 million ARR, annual recurring revenue, and we have over 350 customers. And in terms of the investors, you can see some of the well-known names down at the bottom there. As far as the architecture is concerned, well, previously both the product and the company used to be called MemSQL. And it was focused very much around in-memory OLTP processing. Over time, support for analytics was provided, columnar support, and now we have this kind of universal storage that can handle both types of processing, both OLTP and OLAP. And if we look at the ecosystem, then we can see that there's a variety of technologies that we can integrate with, things like Kafka, for example, and Apache Spark, and even things like HDFS, Hadoop, if you have these kind of legacy systems. The animation here is really showing the ability to ingest data from these in parallel at scale. We work with all three major cloud providers, AWS, Google Cloud, Microsoft Azure, and today I am going to be using AWS for the cloud-based part of the demo. It can be run on-prem. There's a Docker container available as well. One of the unique characteristics of the product, in addition to this universal storage, which we have and others have announced, but we've had this for some time, is this different types of data that we can manage and store. Relational, obviously, that's where the technology has really come from, but we can handle other types as well. Things like geospatial, for example, time series. There's the Lucene full text search engine built in as well, JSON support too, and obviously vectors, which we mentioned a few moments ago. And then finally, just to wrap up this big picture, real-time decisions, AI apps, dynamic experiences, and you can integrate it with a variety of dashboard technologies as well. There's a mechanism to run ad hoc queries, and you can do AI and ML. So this really shows the far-reaching, if you like, capabilities that it is not just a database system now, but a platform that can do far more than just a database system. Let's have a look at some of the sort of issues that we might have in terms of working with a variety of technologies. So here you can see that we have some batch ingest, and maybe we are using something like MySQL for that. Okay, subsequently, we might have some operational requirements, and again, utilizing MySQL for that as well. And subsequently, even we may have some JSON processing requirements. And over time, more things get added. So we may need some caching. Perhaps we want to use something like Redis for that capability. Or we want to use Elasticsearch, if we want to do sort of full text search. Perhaps streaming data through Kafka, and maybe storage and analytics through a data warehouse, such as Snowflake. And then finally, working with Spark. So this, as you can see, the database sprawl in terms of the different technologies that we have to work with becomes quite challenging. And so what SingleStore can do, and the benefit that it brings, it can consolidate all of these. This is great for developers, since there's now only one product to learn. So we can do all of the things that we were doing before, but utilizing just a single product for this. And it's great from a business perspective in that it reduces the total cost of ownership for business leaders and managers and improves the return on investment. So this is the key thing that we see in being able to manage that sprawl through a single product. Some of the ways that we can work with AI and ML with SingleStore, and this list is not exhaustive. These are just some examples. So I've mentioned Spark already, and its mlib library, for example. Python, naturally, very popular today for a lot of data science and machine learning projects. We can integrate very easily with that, and we'll see some examples of that in the demo. The vector functions, we already mentioned that we've had support for that for some time, and some significant enhancements were added earlier this year. And then you're not just constrained by the capabilities of the database engine itself, you can actually extend it. And you can extend that with this thing called Code Engine using WebAssembly. So if you have maybe some exotic piece of machine learning code or something that you want to run, if you can write that up, you can package that up, you can execute that within the database engine in a safe space, okay? And that will give you the extended sort of capabilities beyond what the database engine itself just offers. So that's really, really useful. And of course, working with large language models as well, of which OpenAI is one example, but there are many others available today as well. So what are the considerations that we have in the world of building these kind of retrieval augmented generation RAG apps? Is this need to be able to store these vectors, be able to query the database? And here you can see a very simple example in that we have an end user who asks a question of some Gen AI app that we are building or in the process of building. And then typically parts of that in terms of interrogation would go to the enterprise data currently stored in SingleStore, where we would do some search and retrieval. And again, we'll see this very shortly in the demo itself. And then we would also utilize the capabilities of the LLM to kind of enhance that answer, if you like. So we do the initial prompting and searching with the database system itself. We retrieve back some answer, and then we can utilize that answer with the LLM itself to provide additional context and more information, things that it may not know about, or things that we would like to know more about that it may have more knowledge than we do. And therefore, one consideration then is how do we deal with the concept of working with these LLMs when generally we have to rely upon external sources, in terms of connecting to remote servers, using the APIs and the mechanisms that the LLM provider supports. And so some of the possible ways that we could do this is either through a private subnet, for example, or a virtual private cloud could be possible. So we can run our sort of environment, our database system within this in the cloud somewhere. And we see that some of these cloud providers, such as Amazon, Google, Microsoft, provide private link capabilities, the ability to create these private clouds, and that provides one solution. and even being able to run these kind of commercial LLMs within these environments to some degree. Another possibility is that, well, within the SingleStore compute service that we are now working on, we are planning to support GPU as well as CPU, which is currently already there. And one important development is this ability to really host and run ML and Gen AI models directly within our compute service. So that would be very, very useful for developers in that you now have a local environment, local in the sense that it's local within the compute space itself, rather than having to call some external service somewhere else running in the cloud. So that is something to watch out for, and we plan to provide support for that in the very near future. Another possibility is that we might be running some kind of hybrid environment where part of our system runs locally within our own hosted environment, perhaps something that we have internally, or some kind of private cloud, or even something residing on servers within our organization behind the firewall. So this kind of concept of having this managed service, which is something that we take care of, and then perhaps having some part of the application and the system running in the cloud as well. That is this kind of hybrid scenario, which might work in some cases. So this particular example demonstrates a sort of point of sale example where this might be utilized. And at the same time, we might actually want to make use of an LLM. And in this case, we could do so in either environment. We could do it here in our self-managed environment or in the cloud. So that, again, gives us a lot of flexibility. And then because these are secure, that, again, gives us some level of confidence in terms of being able to work with this technology locally. So I've used the term locally a few times there. And I guess what I'm trying to say is that in the sense that when we work with LLMs, generally we tend to think of them in this way. They tend to be remote. And perhaps typically our database system might be running remote. So generally, we have this kind of scenario where it's this kind of checkbox here. We are running two remote services. And where the concern in terms of privacy and security comes around is typically around this here. How can we deal with this situation? Well, one possibility then is to run the LLM locally. And you can see here that, again, we have some flexibility. So as in the hybrid scenario, we can certainly run our SingleStore database locally. We can run it in the cloud in terms of the compute that we saw, or we could do the hybrid. Any one of these will actually be good solutions. But having this opportunity to have control over where the LLM is running and having that under our control 100% rather than relying upon sort of external services is something that I think a lot of organizations are pondering and considering and thinking about, and could be a very important sort of move for them in terms of managing this for themselves. Okay. So at this point, we've got a couple of demos, but let me just say a couple of words then in terms of the technologies that we're going to use. We're going to use something called Ollama. This is something of a recent development. And what this allows us to do is to run LLMs locally. So that could be locally within, say, a laptop or a server, something behind the firewall, inside our environment. Could be on the cloud. Maybe we're running a sort of cloud environment within our own sort of premises, if you like. That's absolutely fine. That's generally what I'm referring to, something that we have control over. It supports a wide range of models as well. So typically we download these and store these locally within our environment as well. So we don't have to keep going outside to get these. And then these popular models are supported, of which you can see a small list there, such as Llama 3, Phi 3, Mistral, and so on. And then because this gives us the opportunity to really customize and integrate how we want to use it, that again gives us a lot of flexibility in terms of usability. And one of the things that we'll see today is the integration with LangChain, for example, which can save us a lot of time. But Llama Index is another popular framework that could be utilized as well. And then just a couple of words about LangChain. This is really a very useful framework and one worth investing the time and effort to learn, because it can make that task of building and working with LLMs so much easier. A set of standard interfaces and components makes it very, very easy to compose LLM applications. Think of it a bit like how we used to do in the old days, on the sort of terminal where we had pipelines. So you might write, say, a Linux command, and the output of that command then becomes the input to something else. And then that second application processes it, that second part of the pipeline. Then the output of that becomes an input to something else. And so in LangChain, you've got this concept of chains. And again, you can chain these together, these sort of applications to end result. You get something at the end of it, some piece of processing that you want to do, and some output, some result that you're looking for. And you can use these components in order to build that. And it makes that task so much easier to do. And finally, customization as well. Again, lots of opportunities in terms of how you can utilize this, how you can build it with question and answering systems, which again, we'll see an example in the demo itself momentarily. And so the actual environment that I've set up, these steps here, they are described in the assets that you will be given and provided links to momentarily, so you don't need to write these down. But you can see a couple of things here, very, very straightforward. We just need a little bit of information from our SingleStore cloud account in terms of the password and host. Again, the assets that we provide you will show you where to get that information. We need to create a database. As you can see here, that's just for storage. And then you may well have a Jupyter installation within your local environment already, so there's no need to install it, but we do need to launch it. And then there's a little bit of information that we need in terms of utilizing the environment, pointing to our SingleStore instance here. And then basically installing Ollama is a piece of cake. That's all we need to do. This is specifically for Unix, Linux, but equally there are equivalent commands for your Mac and Windows environments as well, will allow you to run that locally. So you can see here that the information, the passwords kind of fills in here, the host details here, and the database, as you can see, is here. So this is kind of stored within our environment, and it's not something that I need to define later on because it's just picked up through the Jupyter Notebook itself. Okay, and with that, let me switch now to my virtual machine, and then I'll walk you through a couple of notebooks there. Okay, so as you can see here, I've got Jupyter running, and I've got a notebook loaded in here. And in this particular example, I am going to run Ollama and connect to SingleStore, and we're going to use LangChain. And let me just walk you through this. Very simple and straightforward. So first thing we need to do here is we'll just install LangChain and Ollama. So let me run that. There we go. That's done. And then the next step just below here, I'm just going to import some libraries. And again, that should be very simple and straightforward. There we go. That's all done. And then within this Jupyter environment, I'm going to use this mini LM, which is going to create the embeddings for me. And then we're going to store those embeddings along with some text in SingleStore remotely. And remember, there is a variable that we mentioned in the slide, which is actually in my environment, and the notebook will pick that up automatically for me. That's why I don't need to specify my password or other details here. So let me run this. Okay, so this is fairly small. It's only 45 megabytes. You can see it comes back very, very quickly. And then for the actual LLM that I'm going to use, again, this is local. Let me run this. This takes a moment or two just to download. Okay, it's about 3.8 gigabytes in size. And once that's loaded, I don't need to repeat this operation. Essentially, it's available for me within my local environment. So that means I've got full control of that now within this environment. There we go. It's done. And then finally, we are ready to actually do something useful. So we have some text here, some sentences. 6 of them in all. Okay, so if we take a look at this, there we go. Things related to llamas. And then all we are doing then is taking each sentence here and treating it as a kind of a document. I mean, you can think of much longer documents if you wish, but this is a good simple example to demonstrate and show this sort of proof of concept. So we are taking those, creating these vector embeddings, and then we are determining what's the length of these embeddings. This is necessary because we need to pass this information along to SingleStore so it knows how to correctly store that. And then finally, we're able to convert these documents to the correct format that we need to store in SingleStore. So let me just run this. Very straightforward, as you can see. This is very fast, and in fact, it's already done. There we go. If I look there, it's completed. And then here is the magic. This is using LangChain to do all of the hard work for us. Essentially, what this is doing, a lot of plumbing, a lot of low-level behind-the-scenes kind of things. So we're saying to LangChain, okay, take all those docs that we've just got up above, all 6 of them. Look at the embeddings as well that you've just been created above. Store these in this table called LangChain_docs for me, and utilize this distance strategy called Euclidean distance. So the 2 distance strategies that SingleStore supports out of the box are dot product and Euclidean distance. So these are just ways to determine how close or how far apart things are. Euclidean distance is great because what we're trying to do then is when we ask a question, we want it to return the closest answer to that. We'll see that in just a moment. And all we need to do then is just execute this, and LangChain will handle all of this for us. It will go away. It will create the table for us. It will store the data for us. And as you can see, it's very, very fast. It's returned extremely quickly. Now we are ready to do that searching. So we have a question that we'd like to ask, and we're going to utilize the embeddings again. So our question is, what animals are llamas related to? What we'll do here is we will convert this text string into a suitable format then. Again, a vector embedding. We send that to SingleStore. We try to match the best answer that is available in the database and return that answer back to us. So if we execute this, there we are. It says, llamas are members of the camelid family, meaning they're pretty closely related to vicuñas and camels. So if we take a look back just at the documents that we stored a little bit earlier, we can see that, in fact, that answer there is one of the answers that we have here. Okay, in fact, it's the very first one. So what it's done is that question has been asked of the database. It's returned the best answer based on Euclidean distance. Okay, so in this case, closer is better. The smaller numbers are better. So that shows that things are closer together. And then finally, we can take that information that's just been returned and then pass it now to the LLM. This is the 3.8 gigabyte file that we had. And if I do this, again, this is running locally within my virtual machine. Takes a moment or two to execute. And there we go. You can see now what it's done is that the LLM has taken the answer that was returned and it's embellished and enhanced it, given us far more information here, as well as a summary right down at the bottom there. And so what this is entirely running within this virtual machine environment. I am not calling anything outside of this environment. Now, let me show you a quick example of LangChain not being used. So in this example, what we've done is exactly the same thing, but just to show you the benefit that LangChain provides, we'll run something very, very similar, but you'll see that I've had to code a lot of the extra parts now myself. So again, we'll just run the first part there, a couple of libraries that we need, and we'll just import those there. Exactly the same in terms of the mini LM to create the embeddings, as well as the Llama 2 there. Okay, and that should actually be faster because it's already downloaded that, so it should be able to pick that up locally. So that should come back fairly quickly. There we are, status success. And then here you can see exactly the same set of documents that we had previously, but now I've had to do a bit more work here. So I still need to create those vector embeddings. I have to have a loop, though. I have to format the data appropriately here and here to build up this kind of data frame, which I have down at the bottom here. And then finally, I get the length again. And you can see that the quantity of code here, if you compare it with the previous example, is somewhat more. So let's just run this. Okay, just make sure that's finished. There it is. And then here, we'll just, again, provide the details of the SingleStore instance. We're going to use a slightly different way to connect to it. SQL Alchemy. And then again, now we want to store these embeddings and these documents in the database. You can see I've had to write some SQL code in order to do that. So this is something that LangChain would have handled for us, but I've had to write this now. And this may be prone to error. I'm not the best developer in terms of SQL code. There may be a typo in there. I might get something wrong, but fortunately for me, in this case, it's worked. And then finally, we can take the data that we've got here and we can store it in that table. And it tells us here that it's stored 6 rows, which is correct. I mean, that's the number of rows that we had. And then finally, when we want to do the similar sort of thing, we do need to create an index, which again, LangChain did for us. And then we have the same scenario, the very same prompt that we asked previously, what animals are llamas related to? But notice here again that the quantity of code is significantly larger here because, again, I've had to write some code myself to manage all of this. Again, prone to error, mistakes. Fortunately for me, the answer comes back exactly the same. Llamas are members of the camelid family, meaning they're pretty closely related to vicuñas and camels. And then the last part here, if we run this, it will give us exactly the same answer or a variation of that answer. There's no guarantee that we would get exactly the same piece of text returned, although the general result will be similar. Okay, so we just wait for that. And there we go. So we can see that it's produced a number of paragraphs there, as well as a summary at the bottom. So the output is not identical to what we saw in the previous example, but the general gist of it and the general sort of content is very, very similar. So it's just that the LLM has returned it in this particular format on this occasion. So you can see the significant benefit that LangChain provides. The fact that we are running all of this in a local environment, although I am connecting to a remote instance of SingleStore, but the Ollama is managing those assets for me within this environment and behind my firewall. I am not calling any external services in order to create the embeddings or to utilize the LLM. And that's the real benefit that this provides for me. Okay, so just to summarize then what we've seen that running a local LLM gives us greater control and privacy, reduces risk of unauthorized access or data breaches, okay, because it's behind our firewall. It's cost effective because we don't have to pay subscription or usage-based billing. There's no money going out. Everything is local. We're able to utilize these ourselves. Faster inference times, reduced latency. We can add additional hardware and additional memory, for example, or storage or processing to improve the response that we get. And customization and fine-tuning, again, gives us a lot of control in terms of utilizing these LLMs locally as well, because now within our environment, we can do pretty much what we want with that. And just to summarize there, any sufficiently advanced technology is indistinguishable from magic. A quote from one of my favorite authors, Arthur C. Clarke. So all of this stuff works really well. It's pretty cool to do. And given the fact that we can now manage it and we can run it, that makes it even better for us. And thank you. Thank you for attending. Thank you for watching this session. And back to you, Vance.
Akmal, wow, what a great overview of the latest incarnation of SingleStore and support for all these AI supportive technologies, which really does streamline that pipeline, as you said, from design to deployment. And really great demo. Who doesn't love a demo? So thanks again for a great session.
Thank you very much, sir.
You know, Akmal, food for thought for many of these capabilities in the demo. But before we get there, a couple of quick questions just to baseline folks on SingleStore and all the great capabilities that you've got. In the early portion of your session, you talked about data sprawl and how SingleStore helps avoid all those issues. That certainly rung a bell with some of our attendees here. There's a question or comment here that says the following. You know, your aggregation of data sprawl offers us a lot of benefit. Does this work as virtual, or are we actually migrating and or transforming our data?
That's a great question, Van. So SingleStore can provide a couple of options there. So we have this CDC technology, change data capture, which can actually connect to a number of external sources. You might recall that I briefly showed that in the hybrid slide that I had. Debezium was the technology I was using. And so that's one way that you can bring data into SingleStore. Or actually, if you want to keep investment in your existing system, whether it's sort of MySQL, for example, or it might be MongoDB, and that can connect to these systems, the data can be fed across into SingleStore, and you can use the benefits of SingleStore in terms of analytics, speed, storage, performance, all of these capabilities, whilst retaining your existing investment. So that way, if you think about it, I mean, the data are kind of flowing from one system to another. Longer term, if you want to consider SingleStore as just the only product that you want to use, then obviously there's a kind of a process that you need to go through in terms of moving that data across. Again, the CDC pipeline will assist with that, but there may be some specifics in your environment. For example, you may have something peculiar, or you may be some code, some processing that you need that needs special attention. We have the necessary technical resources that will be able to assist with that process. We do that all the time working with customers.
Well, and the cherry on top of this whole option, Akmal, to my mind, would be that with CDC, even if I've got a hybrid environment, let's say of single store and legacy,
Yeah,
single store is always going to be up to date because of your CDC capability.
absolutely. That's correct. Yes.
Awesome, awesome. Here's another question about local versus cloud. We understand that privacy makes a great use case for putting data locally, but what are the data store limits? In the cloud, we have virtually unlimited capacity.
Yes, absolutely. So single store, I think it used to be called bottomless, which essentially means that you're not constrained by storage. Pretty much you can have as much as you need. And as you know, storage over time has become much cheaper, and you can add data to it as much as you want. And the nice thing about the way that single store is architected is this separation of storage and compute. So the two are not tied together. You can configure as much storage as you want, and maybe you don't need so much compute power, and you can choose to have less compute power or more compute power, or scale up, scale down as you need it. And that's the nice thing. So the cloud provides unlimited storage if that's really what you need. Of course, you could do that within your own environment as well. I mean, that's in terms of good backup sort of solution, or the hybrid case that we looked at as well. So lots of ways that you could manage this.
Awesome, awesome. Now let's turn to some of the juicy parts here about your demo and pipeline conversation, Akmal. First one here, what are single store's plans for providing integrated LLM support?
Yeah, great question. And so on one of the slides there, you saw me mention that very briefly. So we are actively looking at how we could provide this kind of Ollama or a derivative within our own compute environment. That would be awesome for developers in the sense that now you don't have to worry about, again, that issue of having to pay for some external service to create embeddings or to be able to use these LLMs. You can do that directly within the single store environment. And so it's in the works. I can't provide an exact date as to when it will be available. Typically, what we do is we do an early kind of preview release, and more or less everyone is available to use that. Sometimes it's a private release as well, where we limit it to some customers, but it's in the roadmap. We are actively looking at it, and I'd love to use it myself, that this is something that we'll be able to offer in the very, very near future.
Let's talk about some of the powerful benefits you've got right now, because certainly some of these integrations, while they're very tantalizing, doesn't take away at all from the demo you were able to give us. A couple of quick notes here, Akmal. Your demo was performed in a Jupyter notebook. Is that a pre-configured environment with SingleStore that they set up for us, or do we need to do that ourselves?
That's a great question, Vance. So SingleStore does provide a cloud-based environment. In the demo itself, I was using a local environment. So I was able to execute that code locally on my laptop within a virtual machine and connect securely to a SingleStore cloud instance. So I've got full control over the LLM and the data and the results and everything that's being generated. It sits behind my laptop firewall, entirely within my environment, and I'm connecting securely to my database system, which sits in the cloud somewhere, or I could run it locally as well. That's absolutely fine. No problem there. But the key point here is that I've got full control of my data. I know where the data are, but I do not need to worry about who is seeing my data in terms of the LLM or what's being generated or if the data are being retained. I have absolute control over that now by running everything locally.
Awesome. Awesome. Yeah, really great way to kind of have a sandbox that at the same time, within minutes, could become operational.
Yes. I mean, even if the internet is down and I've got like a server with my LLM installed on it and Ollama and everything right next to my machine, I can do stuff. I can generate embeddings. I can query. There's things that I can do directly. And of course, you recall that we saw that hybrid architecture that I described a little bit earlier. I may have a part of the SingleStore installed locally on my server as well, where I could store the data, and at some point in the future, let's say, the internet went down and it's restored again, it would replicate automatically for me up into the cloud and do so in a secure way. So I get the best of both worlds in that case.
What's so powerful about this Q&A portion, Akmal, is conversation that we're having,
Yeah.
is that you're really helping layer the pieces together of the AI stack or the architecture that SingleStore has really set as the foundation. What I'm hearing you say is SingleStore's native ability to vectorize my data and add all those embeddings really is the piece that leverages all this power you were able to show us today with Ollama and Langchain.
Yes, is a game changer in terms of how people can now start to use this technology, because now they think, right, great, I don't have to pay somebody else to do this. I can install this, do it on my own hardware, and I get the answers back. And it's safe and secure because it's within my environment. So that's the kind of the thinking I think that people have.
Akmal, this has been fantastic. We loved your architecture slides, and the demo really made it tangible for all of us. With time expiring, maybe give us some next steps or final thoughts. What are some resources you would suggest that people go take a look at, both at SingleStore and maybe just in general for people that want to keep their fingers on the pulse of AI?
Oh, that's a great question, Vance. Thank you very much for that. So specifically for SingleStore, we have regular webinars that we run specifically focusing around AI. And we do focus on our own technology, but on related technologies as well. We get some industry speakers. So that's a great way. And then now it's possible to sign up for those and to receive alerts for those regularly. We do have other assets as well. So within our notebook environment, for example, we have this thing called Gallery. There is also something called Spaces, where we provide lots of useful assets. So if you want to work with LLMs, for example, or you want to look for ways to ingest data into SingleStore, there are assets available to show you and examples to demonstrate those. And these can be with synthetic data, for example, and then you can just customize it to your needs if you wish to do so, but it's a great way to get started. And then I think more generally, more broadly, obviously keep up to date with developments in the industry, look at the announcements from the major vendors, the likes of OpenAI, Anthropic, Cohere, for example, and follow the developments with these frameworks. So LangChain is awesome. Llama Index is another one that you should keep your eyes on. So that would be something that I would highly recommend as well.
Awesome. Awesome. Akmal Chandri, Senior Technical Evangelist at SingleStore, thank you very much for a really engaging, terrific presentation with both some great context and a hands-on demo so we can see what it's like in real life. Really enjoyed it, and really, really high-energy Q&A. Thanks a lot, Akmal.
Thank you very much, Vance. Thank you for having me again. Really enjoyed. Thank you.
Totally our pleasure, and thanks to the audience too for some great questions. We might not have had such a high energy Q&A without you. And just a quick note, Akmal had some great list of next steps to go forward. We've got many of the links to those assets right here in the breakout room. And one other that Akmal didn't mention, we have a link directly to a free trial for SingleStore. Alongside that, there'll be a video to show you exactly how to get started and use it. So really great hands-on resources. Download Akmal's slides, and in PDF form, you'll be able to get a list of all these links, take you directly to the SingleStore website for even more in-depth learnings. So again, thanks to our attendees and to Akmal. Really great session. Enjoy the day.